We know that DBT has 5 materializations available for us to use. But what if we want to create our custom materialization? Today, we are going to create a custom materialization live throughout this tutorial. Materializations are macros written in Jinja, and that is why we will have to create some macros and place all of them in our macros folder in a project. Now, before we create our materialization, let's understand what we are going to create. Since this is just a tutorial, we will keep it very simple. We will create a custom materialization just to add an extra column to the model SQL. So let's create our file first. It has to be a SQL file, and the name of the file has to be same to the name of the materialization. We will call it dummy call materialization. We have created our file. Now we will start writing the code. Materialization code has to be enclosed in a materialization macro. Let's do that first. Now we need to pass a couple of parameters here. First, the name of the materialization, which is again dummy call, then the name of the adapter. The adapter can be either Snowflake or Redshift or BigQuery or Databricks, anything. It depends on which database you are using. If you want to write a macro or materialization for all of them, just write default here. Now we will write our actual materialization code. Okay, so let's prepare our tables first. And by tables, I mean the target table that the data will be loaded into. And since we are going to add an extra column, we will need a temporary table as well. So we will create those first. Throughout this tutorial, I'll use the term table and the term relation interchangeably. So let's set our target table first, which is the final table. So this is a keyword that is available in the macros in DBT, and it refers to the target table that is going to be created, or the data from the model is going to be loaded into. We are setting the value of this to our target relation variable. Now we'll set up our temporary relation. Okay, so what I've done here is I have used a predefined make temp relation function. It is a Jinja function that is already written in DBT code. So you don't have to create it yourself. It is already available. All right, so our temporary relation is also created. Now let's consider some scenarios. So the table you're going to create out of the model code that can exist already in the database, or it does not exist, you just have to create for the first time. Let's see if it already exists or not. We will store that status in another variable called existing. Again, I have used another predefined macro function, load cached relation, that will just tell us if the target relation already exists in our database or not. And I have stored the status of that in existing variable. Now we'll just check if it exists or not by looking at the value of the existing variable. Now if it exists, we will do something else. Let's set up the structure first. So our if else block has been built. So if it exists, we will set up the SQL to execute. And if it does not exist, again, we will have to set up another SQL to execute. Let's store that SQL as well in another variable that is called build SQL. Again, you can use any variable as you want. We are just using some DBT standard variable. Let's understand what has happened now. If the table does not exist, we will create it first. So we will set up a SQL that will initially create the table and then load the data. That's why we are creating a function. So this function actually does not exist. We will have to create. So if the table does not exist, we will call this function and it will create the table and then load the data. If it exists, then we will call this function. It will just load the data into it. Okay. Now these functions might need some parameters, but we will see that later. Now there is just one thing we have to consider while creating materialization. That is the case of full refresh. If full refresh happens, we'll have to create the table again. It will just be like dropping the table and then creating the table and then load the data again. I mean, that scenario is actually covered here in this case. So if the table exists, it will be dropped and then recreated. So we will use another condition here just to see if it is full refresh or not. Now, this should full refresh function is actually available out of the box. So you don't have to create it. The next thing is you can have hooks as part of your models. There can be pre-hooks, post-hooks. But before actually we go there, let's do something else. So we have set up everything that is required to build the materialization, but we have not executed anything. If we do not execute anything, nothing will be materialized. That is the most important part of our materialization. Let's do that. And this is where you execute the SQL that you intend to execute in any case. So we have set up our SQL here, build SQL. And for both if and else, we will have the variable name as build SQL. So we can just use that variable here. Now, coming back to hooks. So before you execute the actual build SQL, you have to execute the pre-hooks. Let's execute the pre-hooks here. Yeah. So run hooks function is again available out of the box in DBT, and pre-hooks will actually capture whatever hooks you mentioned for the model. These things are pre-built. Similarly, we execute post hooks right after the build SQL has been executed. Now, last but not the least, we have to return a relation. And by relation, I mean target relation for this case. The relation that is being created out of this materialization. I'll tell you why it is needed, but let's create it first. So return function will take a dictionary as parameter, and it will have the relations keyword and a list of relations that has been created within this materialization that has to be returned here. Now, why do we do this? So DBT will use this information to update the cache. And by updating the cache, the query execution will be optimized. All right, so we have set up everything for our materialization. Well, not everything. We will still have to write these two functions. Now, we can write these two functions in a separate SQL file, but to keep it simple, I'll just write those functions within this SQL file. Okay. So let's create those. Again, those are also macros. So let's create those macros. And we'll start with the keyword macro. That's how macros are written. I'll just copy the names from here. And since we started a macro, we will have to end macro. That's how we create it. And we will do the same thing for the other one. Or let's do that later. So this is the macro for the scenario when the table does not exist or full refresh. So what we need to do here is we will first create our temporary table first out of the model SQL. That means whatever we write in our model, that SQL code will be used to create the temporary table first. And then on top of that, we will read from the temporary table, we will read all the columns, and then we will add our additional column or the extra column, and then we will create our target table. That is our final table. Okay, so let's create the temporary table first. For that, there is again a function available out of the box in DBT. We can use that. This function takes some parameters. It will just create tables with the provided SQL, and it will have to know if the table it is creating is a temporary table or not. Is it a temporary table? That is what the first parameter is saying. We will say yes. So that's true. We are creating actually a temporary table using what? A SQL. So that is actually the last parameter. Let's just write that. SQL. Then before that, we will actually have to give the name or information about the temporary table, which is stored in our temp relation variable. We'll just pass the temp relation here. Yep, that's it. Now our temporary table will be created. And now we have to read from this temporary table, add our extra column, and create our final table. So let's set up the SQL first to read from the temporary table and add our extra column. Okay, so then our macro or set macro, set okay. Since we started a set, we will end set. And now try select now. We're just selecting That's it. Now we will have to add our extra column. Let's say a value for that extra column will be dummy value, as the name of the extra column is dummy column. Yeah, simple as that. And that will be our final data. Now, if you see, we are using temporary relation variable, but we have not passed it to this function. So let's do that. Also, we are using the SQL. This is actually the model SQL that was provided to the materialization. It is automatically available within the materialization, but it is available in the materialization macro, not in here. So we will also have to pass that. Yeah. All right. Now that we have set our SQL for the target table, we will create our target table. We will use the same thing. Let's just copy and paste. Yeah. But this time, this is not a temporary table. And the difference between temporary table or temporary relation and target relation is that temporary relation will be deleted after use. So there will be a cleanup phase, which will be done automatically by DBT that will remove all those temporary relations. Anyways, now we are creating our target table, which is the final table. So this is not a temporary table, and we will say false here. And this is our target relation, obviously. Now we are using the target relation variable from our materialization macro. So target relation has to be passed on to this macro as well. Okay. And the SQL is not the model SQL anymore because that was used to create the temporary table. Now we will use our extra call SQL to create our target table. And that's it. That is all we need for this function. Now we have to remember that we have to pass this function parameters from here, because this was just the definition of the function, but this is where we are passing all the parameters. Yep, all good. Now we will do the same thing for this function, which means we will build this function now. It will somewhat look similar to that one, but a little bit different. We'll just copy. That's easy. We will change the name and we will see which parameters we need. And actually, we know we need all these three parameters because we will again have to create the temporary relation first. Then out of that temporary relation, we will add the extra column and then the target relation. And we will obviously need the SQL to build the temporary relation in the first place. So we will need all three parameters. So we will add these three parameters in here as well, where we're calling it. Yeah. Okay. Now we have created our temporary table. That is good. Then we will just change these things. We will remove these things. What we have to do is this time we have our existing table in the database. So first we will get all the column names from our table, because this time we are inserting data into the table. We are not creating the table. So we will get all the column names, then we will insert values into it, because the insert SQL statement looks somewhat like this. Let's write that first. We will pass on the column names here. So let's just say columns. This is a variable where we will have all the columns. We will change it when we actually write the definition for it. And then with the data from our temporary table, of course, we will have to add our extra column with dummy value. Yep, that's all we need, except for the fact that we have to define the columns, or we have to extract the columns from the actual target table and then pass it on here. Now it's a two-step process. First, we will get the column names. Let's call it target columns. And for that, we have existing macros available or existing functions available in DBT that we can use, and that those things are available under adapter, because for different adapter, this mechanism of this function will be different. Adapter dot we pass on the table name or the table information here. This is our target table, so we want to extract the columns from our target table. This is how we do it. Now this table or these target columns have many info regarding the columns, including the name. So it will have the name and maybe the data types of the columns and etc. But we just need the names. So we will extract the names from this. And we will have quotations around the column names. That will help us in different scenarios. So let's just have it. We will call this variable quoted CSV columns, and we're calling it CSV columns because the columns will be in quotations and separated by commas. Now this get quoted CSV function is again available already in DBT core, so you don't have to write it yourself. Target columns is something we have defined here, and as I said, this target columns will have information about the columns, about names and the data types and all other things. So first we are extracting just the column names using this map function. So you see the attribute name, we're extracting the attribute name from this, from each column information. And then we are passing it on to this function that will just enclose the column names with quotations, and then it will have a list, it will create a list out of those all column names in code, and they will be separated by commas. So comma separated quoted column names. That's what this is. A list of comma separated quoted column names. This is what we will use here, because that's what we need. So we just need the list of columns that we are going to insert the data into. Right. And since the table already exists, this column already exists because we have created this column initially. That's why this column also exists. So we just are adding the data into it here. And that's what we need for the get dummy cosql function. The function is already being called here, and we are passing all the required parameters. So I guess this is all we need to create a custom materialization. Now, of course, we have created our custom materialization, but we have to test it first to see if it works. Right? Now, we will create a model, just a dummy model, let's say. We can create it anywhere. We'll just try it to see if it works or not. We will call it dummy model for SQL. And we will just select, say, from the customers table, or we can select from anything just for the sake of testing. Select from reference, yeah, model name is customers, and we'll add the config to use our custom materialization. Config, and our materialization name is dummy call. That's it. That's all we need for testing. Now, what we expect to see in this dummy model or the dummy table in the database is that we will see all the columns from our customers table and an extra column, dummy column. Okay, so let's run it. Fingers crossed. Okay, so we have made a mistake. Okay, we have found our issue. So we just have to say set here because that's how you set variable. Now let's run our model. Okay, there is a typo. Let's fix this. No, we have the wrong thing. So let's run our model. We were running the materialization. Now it's running. And our dummy model is created. So let's look at Snowflake. Okay, let's see. Yeah, dummy model is created, but just to see for confirmation, we will drop the dummy model and we'll create it again. Yep, dummy model is dropped. We'll run it again just to see. It's not there. Run it. Okay, we run the model and let's see if the table exists. Yes, now the table exists. Now we will look at our customers table first and look at the columns, and then we will look at the dummy model to see if we have our additional column or not. All right, let's look at the preview data for customers table. Yeah, there is no dummy column in it. We will look at again and we don't see any dummy column here. Now we will look at our dummy model and just click on it. We see the dummy column. Let's look at the value. Yeah, do we see the dummy column? Yes. That's how we create our custom materialization. And what we have done in this tutorial is that we have created our custom materialization. We have made mistakes. We have fixed those mistakes. And voila, our custom materialization is ready. Thank you for watching.